Okay, this is a helicopter flying handbook, chapter 9, basic flight maneuvers, be page 1 through 20. This will be page 1, introduction. From the previous chapters, it should be apparent that no two helicopters perform the same, even when flying the same model of helicopter. Wind, temperature, humidity, weight, and equipment make it difficult to predict just how the helicopter will perform. Therefore, this chapter presents the basic flight maneuvers in a way that would apply to the majority of helicopters. In most cases, the techniques described apply to small training helicopters with a single main rotor rotating in counterclockwise direction, looking downward on the rotor, and anti-torque system. Where a technique differs, it is noted. For example, a power increase on a helicopter with a clockwise rotor system requires right anti-torque pedal pressure instead of left pressure. In many cases, the terminology apply proper pedal pressure is used to indicate both types of rotor system. However, when discussing throttle coordination to maintain proper rotations per minute, there is no differentiation between those helicopters with a governor and those without. In a sense, a governor is doing the work for you. In addition, instead of using the term collective pitch control and cyclic pitch control throughout the chapter, these controls are referred to as just collective and cyclic. Because helicopter performance varies with weather, conditions, and aircraft loading, specific nose attitudes and power settings are not detailed in this handbook. In addition, this chapter does not detail every attitude of a helicopter in the various flight maneuvers, nor every move that must be made in order to perform a given maneuver. When a maneuver is presented, there is a brief description followed by the technique to accomplish the maneuver. In most cases, there are a list of common errors at the end of the discussion. So, the four fundamentals. There are four fundamentals of flight upon which all maneuvers are based: straight and level flight, turns, climbs, and descents. All controlled flight maneuvers consist of one or more of the four fundamentals of flight. If a student pilot is able to perform these maneuvers well, and the student's proficiency is based on accurate feel and control analysis rather than mechanical movements, the ability to perform any assigned maneuver is only a matter of obtaining a clear visual and mental conception of it. The flight instructor must impart a good knowledge of these basic elements to the student and must combine them and plan their practices so that perfect performance of each is instinctive without conscious effort. The importance of this is to the success of flight training cannot be overemphasized. As the student progresses to more complex maneuvers, discounting any difficulties in visualizing the maneuvers, most student difficulties are caused by lack of training, practice, or understanding of the principles of one or more of the fundamentals. All right, so guidelines. The guidelines. Good practices to follow during maneuvering flight include: move the cyclic only as fast as trim, torque, and rotor can be manipulated. When entering a maneuver and the trim, rotor, or torque reacts quicker than anticipated, pilot limitations have been exceeded. If continued, an aircraft limitation will be exceeded. Perform the maneuver with less intensity until all aspects of the machine can be controlled. The pilot must be aware of the sensitivity of flight controls due to the high speed of the main rotor. Anticipate changes in aircraft performance due to the loading of environmental conditions. The normal collective increase to check rotor speed at sea level standard (SLS) may not be sufficient at 4,000 feet pressure, altitude, and 95 degrees Fahrenheit. Anticipate the following characteristics during aggressive maneuvering flight and adjust or lead with collective as necessary to maintain trim and torque. Left turns, torque increases, more anti-torque. This applies to most helicopters, but not all. Right turns, torque decreases, less anti-torque. This applies to most helicopters, but not all. Application of aft cyclic, torque decreases and rotor speed increases. Application of forward cyclic, especially when immediately following aft cyclic application, torque increases and rotor speed decreases. Always leave a way out. Know where the winds are. Engine failures occur during power changes and cruise flight. Crew coordination is critical. Everyone needs to be careful to be fully aware of what is going on, and each crew member has a specific duty. In steep turns, the nose drops. In most cases, energy airspeed must be traded to maintain altitude, as the required excess energy power may not be available to maintain airspeed in a 2G or 60-degree turn. Rotor thrust engine power must increase by 100%. Failure to anticipate this at low altitude endangers the crew and passengers. The rate of pitch change is proportional to gross weight and density altitude. Many overtorques during flight occur as the aircraft unloads from high G maneuvers. This is due to insufficient collective reduction following the increase to maintain consistent torque and rotor RPM as G loading increased. Dive recovery or recovery from high G turns to the right. Normal helicopter landings usually require high power settings with terminations to a hover requiring the highest power setting. The cyclic position relative to the horizon determines the helicopter's travel and attitude. So we'll leave it there. That was page 1 and 2 of Chapter 9, Basic Flight Maneuvers. All right, take care. Bye.